All right, so after the general presentation on the state of the Tomcat, we're going to focus more about on new and upcoming features. Mostly new features that have been introduced fairly recently, starting from Tomcat 8 up till what we have in 8.5 and 9. So I'm Rémi Mochera. I work at Red Hat now. I've been working on Tomcat since 2000, originally at Sun, then at JBoss. And I've been an ISF member for many years. I don't remember when I was nominated as a member, actually. It's too long ago. Okay, so basically the new features that we'll talk about are the most interesting ones, HTTP2, which is going to interest pretty much everyone, I think, because it's a big new thing in the internet world now. Also, the OpenSSL support that Mark has talked about a bit before. And the most interesting upcoming feature is cloud clustering. We're going to try to enable Tomcat clustering to work seamlessly on the cloud, because right now it doesn't work very well. So starting off with the base of a lot of other work, we are going to talk about the NIO2 connector. Originally, it was added in Tomcat 8.0 as experimental. So, and what NIO2 is an alternative I/O API to NIO. Basically, we wanted to experiment with it because the NIO poller code was too complex. NIO polling is used because NIO is a non-blocking I/O, as probably a lot of you know. And you have to be notified basically when operations are able to complete. And so you have a lot of polling code to be able to do that, to be able to complete your read and writes. So we found out in the experimentation that NIO2 is very clean API. It's very nice. It has nice blocking semantics to be able to do all the blocking I/O we do in servlets very nicely and cleanly. It also has obviously asynchronous semantics, because NIO2 is at its core an asynchronous I/O API. Basically, what it does is that when you do a read or write operation, you give it a callback, and then when the operation has completed at least partially, the framework will call back your callback, so that you know your operation has progressed. It also allows advanced I/O, which is called scatter and gather. So what it does is that it changes the buffering strategy of I/O and tries to do zero copy. So for example, when using gather, it's a write operation that allows taking multiple buffers and writing them all in a single I/O operation, rather than having to buffer your data inside a single buffer, therefore doing one needless copy of your data and then passing that big buffer to the network stack. So basically it allows doing zero copy, which is very trendy in networking and also in other fields, like in graphics APIs. Zero copy is pretty popular as well. So all that could be realized using NIO2, so that's what we wanted to achieve. Also, another benefit is that I/O code inside the JVM and was very crafty with NIO and stuff. It was old and not always very well maintained. The new NIO2 is all brand new code. That also means new bugs, but at least it's new clean code. Yeah, because you get new bugs with a very new code, but at least it's a good basic. It's basis. It's very clean and very nice to read. So that's good. So, as I said, it's included as experimental in Tomcat 8.0, and now it's fully supported by myself and Mark. We found out it actually has good performance because it's a very verbose API compared to NIO or Java I/O, but in practice it gives out a lot of good performance despite its look, because you didn't expect it to run very fast originally with all these callbacks and asynchronous behaviors and stuff. So load testing actually found it very promising. As a result, the NIO2 connector is easier to read, at least it's more pleasant. So that's one of the goals that was achieved. And also the gather I/O, which is a write optimization, allowed improving actually HTTP2 performance and reduce the latency. So that's a very important achievement, and it actually validates the concept of digging further in that area. So what we have found with NIO2 is that although the code was cleaner, the state handling of the API is actually more complex, because since it's asynchronous, when you start, for example, writing stuff, you get a callback later than that the write call has completed, at least partially. But the thing is that while it's going on, you don't really know what happened. Some operations complete immediately at the end of the write call. Basically, it completes inline. But sometimes it doesn't. It completes asynchronously inside another thread inside the JVM. And it's very complex at the moment with NIO2 to keep track of that. So that's an issue we had to deal with. Also, scatter IO, which is the read portion, is pretty difficult to use for us because it's meant to be used for fixed-sized protocols, binary ones, which use basically, for example, you have a packet with a fixed-length header and then a fixed-length checksum or whatever. And so you can use multiple buffers to fit the data very neatly inside a single read operation. But we don't have many of these protocols inside Tomcat. WebSocket is some slightly fixed-length protocol, HTTP2 as well, but it's not that fixed because there's a lot of variation between all the packet types, and it's pretty hard to use. This I hoped to be able to find better optimizations that I did. So there's still an area where we have to progress. Also, garbage collection. I don't know if it's important in your deployments, but if it is, NIO2 generates lots of garbage because every operation is an asynchronous call, and it has to use a callback handler, and all that means a lot of new objects all the time, and all these objects have to be garbage collected. So what we found out was garbage collection was vastly more efficient than what it was 10 years ago. So NIO2 works pretty well in that area in practice, but it still generates a lot of more garbage than other APIs like Java.io or NIO or APR. Also, to be able to optimize everything, you have to essentially get rid of the extra buffering copies that we've done in the container and take advantage of scattering and gathering. And so that means the buffering strategy is very different, and we need to refactor Tomcat to be able to use that in the most efficient way. Also, when we use SSL, as you know, SSL takes data that is written or read and encrypts it or decrypts it, and that means also another step of buffering, basically, because you need to put your encrypted data in a buffer, decrypt it, and get that in another buffer, and so that's another buffering state. And since you're not going straight from the application buffer to the network layer, you introduce byte copyings and stuff, plus the encryption cost, and that can mitigate the gain we hope to gain on the basically I/O efficiency front. Okay, so what we want to do with NIO2 going forward is improve the API we use to allow scattering and gathering, attempt more use of scatter to optimize input. What it could do for HTTP2, for example, is make the reading less blocking and more efficient. Also, we want to use more low-level API, for example, with WebSockets. It could be an area where we could introduce direct calls and optimize that buffering at the container level. Okay, another completely different feature that we could work on is password encryption. What password encryption means is that, well, you have your data source inside your server.xml, and the data source needs a password, and so your password is in plain text inside server.xml, and nobody really wants that, right? So we want to try to improve that. At least we considered the issue at some point, and we have some techniques actually. We have an extension hook in the Tomcat digester. The digester in Tomcat is utility that is used that uses a set of rules to parse all the XML files in Tomcat. So basically, since we have an extension hook there, we can intercept data that is read and from the XML and decrypt any encrypted values that could be present. So that would be nice. The downside to that implementation is that although it works, it doesn't provide any big security. It's only an obfuscation, because basically all the encrypted values are no longer on the hard drive, which is good, but they're still decrypted into memory and they could be intercepted by a more determined hacker and stuff. So, but it's still an improvement, it's an obfuscation. The problem is that, well, the inclusion was blocked by the Tomcat community, since we don't like introducing features that that are only obfuscation, and we wanted to provide real security. Anyway, the feature is available as a third-party component at the moment, and maybe we'll revisit its inclusion later. I don't know if Tomcat likes that kind of feature or not. We'll see. Okay, so moving on to HTTP. So we have introduced HTTP2 thanks to Mark. Nearly everything was done by Mark, actually.
The HPAC stuff came from Red Hat.
Okay, yeah, that's true. Okay, we contributed a bit of HTTP2. So it's the next big version of the HTTP protocol. It's been actually adopted very, very quickly. I was actually surprised. I expected it to take a lot longer than it did, but Google did a lot by introducing it in Chrome, and Firefox followed on pretty quick, so everything was good actually, and servers picked it up very well, and so we are very lucky that Mark did it very quickly in Tomcat 8.5 and 9, because we were ready from the get-go for HTTP2. So the main goal of the API was to lower latency by more efficiently using connections and doing less stuff in parallel connections, which could cause scalability problems. And all that yielded actually results, because for actual benchmarks on latency, it actually performs much better than HTTP1. So it's integrated and fully supported in Tomcat 8.5 and 9. It does still need extra configurations. It's not enabled by default. You need to add a protocol handler element on the connector to enable HTTP2. The thing is that it's not default because it's pretty hard to put in production, because it then needs browser support, which is ALPN, which is needed to be supported by the browser. And to get that, you have to configure stuff. So basically, you have to configure a lot more than actual protocol handler. I'll talk about it in a few minutes. What we found is that the implementation that is in Tomcat has good actual performance. I tested it with H2 load, which is the equivalent of the Apache bench, but for HTTP2. And to make sure I'm not actually testing the encryption performance, I mostly tested unencrypted. And so it actually had much better performance than I expected, more in line with HTTP1, which was a pleasant surprise, a bit like what we found with NIO2. Also, we do support direct H2 connections for proxying. That allows avoiding ALPN, which can sometimes be useful. Okay, so what the issues are at the moment is that to get actual browser support, like to be able to connect from Chrome or Firefox, you need ALPN, which is an extension of TLS. And then the TLS configuration needed is actually pretty demanding. You need to have a real certificate for the server. It has to be signed by some authorities and the browser recognize. Then also the TLS configuration actually has to be secure. That means has to be secure according to Google. That is really secure. And so it's pretty hard to put in production. And so it doesn't make much sense, I think, to enable HTTP2 by default at the moment. What we also have, I talked about it in NIO2, is that we still have some blocking I/O going on, especially in reading. We have less blocking I/O at the moment, for example, used in HTTP1, so that's a bit of an improvement that can be made. Unfortunately, the code is also more complex for parsing headers. It's more complex than what we have in HTTP1, so it takes more design effort to do it the same in HTTP2, so that will be done in later on. Also, what we found is that it goes along with JSSC. We found that encryption performance was actually a bit low. So that's something we could work on, hopefully. Yeah, the GC is a bit like NIO2. The garbage collection of the HTTP2 code is much higher than the HTTP 1.1 code, which is almost zero garbage collection. So that's something to think about in production. But the thing is that it still performs very well. Overall, the resource use compared to HTTP1 is actually bigger. A single connection of a client like Chrome making HTTP2 requests will use more threads in parallel than an equivalent HTTP 1.1 traffic. And so the memory and thread use is going to be higher. So that's also something to keep in mind. Although even though for the client it will actually seem to perform better. Your website will perform better with HTTP2 because of the lower latency, but to run your server you'll need a lot bigger hardware basically. That's what thing is, I guess, in the software industry. What we'll do next? So I'll try to use NIO2 to reduce the blocking code which we still have in for reads. Basically, as with HTTP 1.1, I'd like to do frame header reading at least non-blocking, I mean asynchronously.
Sorry, quick question. You know, when you said you're running HTTP2, you need a bigger hardware. Are you saying
yes,
whatever you're running your HTTP1 X on, you should be doubling the resources?
Yeah, it's mostly memory because the memory use of the structures inside the HTTP2 code in Tomcat are higher, and also the thread use is going to be higher. Because basically what HTTP2 does is that it multiplexes many requests over a single connection, but internally that connection is going to split up individual streams, which is multiplexing, and all these streams are going in Tomcat to be assigned in its own thread, and so you could have one connection, for example, which H2 load, you can notice the behavior, which actually splits up into hundreds of parallel threads if you're not careful. And so that means that you only have one connection and hundreds of threads, unlike HTTP 1.1, where at worst you have one connection, you have one thread on the other hand. So it's a lot more controllable and intuitive with HTTP 1.1, and if you're not careful, really, HTTP 2 resource consumption can explode. That's what I think Mark hinted about a few minutes ago when he talked about DOS with HTTP2. It can happen very quickly if you're not careful about your configuration.
So it's not a case of creating an object and other connections using that object to multiplex. It's every connection you create an object and then do the multiplex.
Yeah. Yeah, because basically it's still the same as before. You have your servlets, which are regular servlets, and they get incoming HTTP2 traffic, but in the background, in the container, everything is multiplexed over a single connection, but all your servlets are still executed as before in parallel. They're still using the old I/O API from the servlet API, so they are writing and reading the data transparently as they did before, and so every servlet needs to have its own thread as before, and then it's all multiplexed by the container into a single connection. And it poses all sorts of problems. Basically, you have to control the amount of multiplexing you get, and also it can cause a synchronization bottleneck, because you could have a lot of parallel streams inside a connection or writing to that single network connection, while before they had a lot more, well, each had their own connection. And it only causes a synchronization not deadlock, but a bottleneck to write to the networks then. Okay, so one difficulty we had is that Java 9 support wasn't Java 9 brought support for LPN, which is a needed block for HTTP2, and obviously it wasn't there. So we hope it will become ubiquitous soon, so that we can avoid that problem for new users. Basically, they need to get support for LPN, so they need Java 9 basically. So we hope, as I said, scatter I/O will mean more efficient asynchronous frame parsing. We'll see how it goes in practice, but at least that's the goal. Maybe further performance tuning. We'll see how it goes in that area, although we found out with load testing that HTTP2 was very performant already. Congratulations. Oops. And we hope to support more HTTP features eventually. We'll see about that. There's a lot of stuff like stream dependencies and stuff. I don't know how much we'll do about it eventually. Okay. We'll see, because basically a lot of features in HTTP 1.1 weren't implemented until were never implemented actually. So we'll see about it. A lot of exciting work on HTTP 2 at least. So going along with that, we have the OpenSSL support Mark talked about. We thought JSSE was slow compared to what OpenSSL brought, since we knew the APR connector was much faster than the Java I/O or NIO connectors for encrypted traffic. So that's one thing we wanted to get, faster encryption. Also, we found that it was the only supportable option to get ALPN support before Java 9, because some hacks were implemented to support ALPN over Java 8. But the problem is that there's a supportability issue, since it needs to use specific hacks for specific JVMs, so it's more complex for the users to deploy. While we were confident that since people were actually using the APR connectors, they would be more comfortable just using that OpenSSL support that came along with the APR connector. Also, eventually, we thought we could reduce the native code footprint. The native code will only be focused on encryption and decryption and not handling the sockets and everything like the APR connector does. That's less opportunity for crashes and problems. Yeah. So what we did actually, rather than using JCE, JCE is a normal extension point for JSSE. It's a Java cryptographic extension. It allows normally plugging external cryptographic engine into the JVM. And we decided not to use it because it's very complex. Also, it needs configuration at the JVM level, which is not very convenient to do. And instead, we found out some other project, Netty, had done an experiment with an SSL engine which could be hacked in a way that the JVM would allow using that SSL engine, even though that extension point wasn't apparently explicitly supported. But at least we found out we could plug in our OpenSSL support package it into an SSL engine that would then hook the encryption and decryption through the OpenSSL library directly. So we were pleasantly surprised that it actually worked. So, but unfortunately, since we didn't use JCE to implement that, it doesn't work with Java I/O, which will have to go through JCE, and will never use the SSL engine, which is only used by NIO and NIO2. So basically, we made a solution that would only work with NIO and NIO2. So what we found out, it has really great performance. Essentially, the encrypted SSL traffic performs as well, or almost as well as the APR connector, which really fit exactly what we needed. It's not any faster, but at least it's the same, which was found to be very good for everyone so far. So we are very happy about the performance. We hoped, like we were a bit fearful we'd run into problems with synchronization and all that kind of stuff, because accessing the native libraries needed synchronization and being extra careful to avoid crashes due to concurrent closing of sockets or everything. And so that extra synchronization made it look like it could perform worse, but thankfully nothing happened. Everything's good. So as a result, it provides ALPN for the NIO and NIO2 connectors, very important. We got HTTP2 just working just fine out of the box. As soon as Tomcat Native is installed, NIO2 and NIO can support HTTP2 with Chrome and Firefox. So the setup is then very similar to the APR connector. You take your Tomcat Native library, you install it, and then it should work out of the box. The code for handling key store and trust stores, unfortunately, is a bit more complex because we have to pass all that information to OpenSSL. We found numerous bugs in that, regressions, problems. Hopefully, it's behind us now. Everything is fixed. Good luck. Thanks. Thanks, Mark. You did great. So normally, everything is fixed. The main benefit of the whole work is that actually we have full OpenSSL configuration capabilities that you can use through the NIO and NIO2 connectors. And also you can use your certificates from OpenSSL, exactly the same configuration you'd use in Apache, you can use it in Tomcat now. And you can also use the key store and trust stores. That's a support we have added recently. Originally, when we added OpenSSL to NIO and NIO2, you had to use the OpenSSL classic way to handle certificates and essentially do it the same way that you did in Apache, but that's no longer the case. So what we can do next? Sometimes we still find a crash bug. We found it fairly recently dealing with SSL session access, because accessing the SSL session sometimes is asynchronous, and we could still access it while the SSL internal structures were being destroyed. That would cause a crash since it was an invalid access to an unallocated memory, so that crashed the VM. That's not good. Hopefully we fixed everything, but that's still a risk we have over JSSE. Eventually, as Mark said, we may remove the APR connector because since the performance is fairly similar to what we have in APR, since also we support all the certificate configuration we could hope to support. Everything's good. We don't need the rest of the APR connector, which is pretty complex stuff, at least more than NIO and NIO2, I think. And so we could take the opportunity to remove all that extra native code to interface with all the APR structures. Now, that's a big chunk of code, actually. So we would hope to get rid of that eventually. The only problem, I think, to actually do it is that there's little incentive. It's only a cleanup, and we are still removing support for the APR connector, which some people might use. We had already a lot of complaints with the Java I/O connector removal. So if we remove the APR connector, we might get as well a lot of complaints. Maybe some guy finding that for him, the APR connector works better or it's more performance than the others. Who knows? But yeah, that's a big risk. What we need to add also is support for the OpenSSL clones like libSSL and BoringSSL. So libSSL has been done already. Essentially, it's not a lot of work, but basically we need to test it and try it and add a few if-defs. Then something we can do is modernize the native code, because some of the code in Tomcat native is not up to the current C standards. I'm not going to do that since I don't do a lot of C now, or at all. But that's still an area that could be improved. For example, some utility calls from APR are used while there are equivalents now in the standard C libraries, at least in the more modern ones, so that areas where gratuitous use of APR stuff could be removed in favor of standard stuff. So a lot of cleanup is possible there. Okay, so Mark talked a bit about it, but reactive I/O was reintroduced in Tomcat. Basically, what it does, it allows the ability to pause input, because what we have in Servlet 3.1 is that you subscribe a listener to get read events. So every time data comes in, your listener gets called, and it tells you can read data, so then you read your data, no problem. The problem is that if the data input comes too quickly, it can swamp your backend, because your backend will get lots of events that maybe it won't have time to process. So we wanted to add the ability to pause input. So basically, you tell your the container, please don't call my listener for a while. And somehow that wasn't included in Servlet 3.1. I think that's an oversight, because if I had thought about it, I would have proposed it at the time, but unfortunately, I didn't. I didn't notice that absence, unfortunately. So what we did is that suspend resume is included for WebSockets. So because the WebSockets framework takes over the parsing of the processing of the events for the application, and then calls the endpoints, the appropriate endpoints according to these, and that can be done transparently by the WebSocket implementation. So it can pause, suspend the listener calls while the backend work completes, and then resume, and that get the backlog of events from the input. More generally, it will allow pausing and resuming all the servlet 3.1 input events. Also to note, we are working with an IO2, and that the asynchronous nature of an IO2 is something that is naturally fixed by, naturally addresses this issue. Because basically, if you don't read, you're not going to get a callback. You only get one callback per read, which makes reactivity of the input very straightforward. Okay, so now Jean-Frédéric will talk about it more later with a demo, but I wanted to talk about it. It's a very important issue at the moment. Basically, with cloud being so popular, we wanted to have something working with the Tomcat clustering. Basically, being able to deploy new Tomcat instances, have them join your session clustering seamlessly and stuff like that. The problem is that it actually doesn't work at all in the cloud, since multicast is used for Tomcat clustering, and the cloud doesn't work with multicast. So what we have is only static membership, and it's not flexible. So we needed something more ready to use. So we did an experiment with Jean-Frédéric and some students, and we found out some way to implement it using the Kubernetes API. You get a JSON list of members, which is dynamic. And by using a special implementation of the Tomcat membership service for the cluster, you can add those newly discovered members from the cloud to your session replication cluster. So at the moment, we only have an integration with Tomcat embedded, but more will come later. Jean-Frédéric will do a demonstration of that feature in the next, I don't know if it's the next presentation, but maybe it's the one after that. We have the code, I've written it in the presentations for reference. It's Tomcat in the cloud in github.com. Okay, so one last thing I wanted to talk about, because it comes back once in a while, is Mavenizing Tomcat. It's mostly for development and embedding. And a lot of people usually ask that, and then Mark doesn't like it. Before, it was me who didn't like it, so there's always a lot of people who didn't like Maven inside Tomcat. But that's an area we could work on, Mavenize Tomcat finally, and maybe the Java 9 modules, we'll see. What it would mean eventually is basically easier Tomcat embedded use, since Tomcat is mostly used standalone and not embedded. Also, we think it's pretty competent in embedded, actually, although it's even less popular. So the implementation, would only be done in the next major release, because it will need re-architecting of the whole repository. We won't do it in Tomcat 9. And there's no community agreement on that yet. And that's all I have for today for major features. So you can contribute new feature ideas. For example, we have had some pretty major feature contributed recently. For example, with the WebSocket client. The WebSocket client, which is included in Tomcat, implements the specification, which means it implements the spec, but it's actually unusable in production, since it didn't support all the HTTP features needed for an actual WebSocket client to work, like authentication or anything. It only supported upgrading. So basically, some external contributor contributed code to do redirects, I think. Yeah, and authentication, most importantly, because basically without authentication, you can only connect to unsecured WebSocket endpoints, which is probably not going to cover any use cases in practice. So now we've covered that feature thanks to the community. So your input is very important, and contributions also. So any questions?
thought about clustering in Docker?
Yes,
Yeah,
his talk.
Oh.
Yeah, basically he'll do a demo with Docker containers, I think.
Yes.
Yes, so
Kind of.
yeah, basically that's what we want to do, and we think we have a good solution. At least it worked very well so far in the experimental phase, and so we want to basically be able to make Tomcat clustering still relevant, because right now it's pretty much unusable, I think. Also, one thing I didn't talk about for future major features, we get security reports about it once in a while, is that basically our cluster membership service and generally the clustering is not secured. You need to have network security to be able to use Tomcat session replication. Because, for example, any node that comes up inside your multicast setup will join the cluster, and if it's a rogue node, he'll be able to get all the session traffic, all the session data from all the Tomcats. It'd be able to inject also some deserialization problems and stuff like that. So you have to have network security at the moment to use the Tomcat session clustering. We never claimed it was secure without it. And maybe we want to make that secure, at least with additional configurations. Configuration, unfortunately, would have to be a bit complex, because it probably would have to use some certificate membership, some certificate validation, all that kind of stuff. So it's not going to be pretty, but I think we want to have support for that. Basically, the secure membership and then secure traffic between the nodes.
That's a tricky topic.
Yeah, that's a tricky topic. Yeah, it will cost a lot in terms of performance, of course, if we do the full encryption of all the network traffic. But
In the cloud, or
yeah, in the cloud.
even internally, I think very soon someone's going to come with the thing like, okay, you can't have a cluster which is not encrypting the data between the nodes.
So anything else? We still have some time.
You mentioned if you want to have secure traffic across all the nodes, that is expensive. I mean, you're talking expensive as in terms of overhead on the.
Yes, well, it will take a lot of computational resources on the server. Because there's a lot, basically, you have a lot of nodes, you have a lot of traffic between them. But yeah, I think it will be unavoidable at some point. Basically, the security practices are going to mandate that your clustering has to be secure. At the moment, I don't know if it's really set in stone, so we don't do it. And few people complain, but not too many.
They need to bleed something in.
Yeah, at some point, probably.
But you could do showing your Docker containers, so all their traffic's encrypted when they talk to each other.
Yeah, the big problem is things changing the keys. Especially if you have something dynamic, it requires factory to again.
You can do all that at the network layer, indeed.
So take it out of Tomcat.
Yeah.
Never allow you've got it.
Yeah, actually, I think it's Christopher Schulz who talked about it. Talked about doing it at the network layer without intervention from Tomcat, I think.
Yeah,
But-
DSL. It's DSL.
Okay, anything else? Or we're done? A bit early, but that's okay. Yes?
A question probably more for Mark. Am I right in thinking we're doing a Ask You Awkward Questions at 4?
Yes.
Yes.
Okay, I'll hold on to my SSL questions till
No,
4.
oh,
We've
yeah.
already been discussing that awkward one, and thank you very much.
Yeah, there's a big ask any questions, but yeah. If it's specifically about big new features, maybe they can go there instead. All right, so I think we're done. Thank you. How do I stop the recording now? Thank you. Ah.